9. Applying. Pythagorean theorem. No. You just used Pythagorean. They were applying. Okay, again, that is the theorem. A squared plus b squared equals c squared. The lengths of your legs squared added together equals the square of your hypotenuse.
Can I move up? No.
All right, so example 1. We got 3 examples for you today. Find the distance between 2 points.
Oh, buddy.
All right. So, given 2 points, 4, 1, and 3, negative 2. All right.
Quentin, you want to do this?
Yeah. Oh, man.
All right, so let's look at this on a graph, which you guys really do an easy job figuring this out. So 4, 1 is right here, and 3, negative 2 is down here. I want to know the distance to those 2 points. Okay? So, I can make a right triangle. Now, can somebody tell me the length of this leg over here? Yes? It's 3 units. So this dot here is at this y coordinate of 1. This dot here is at the y coordinate of negative 2. 1, 2, 3 units. Yeah.
Oh, it's good.
You got it?
Yeah.
Okay. Yes.
What is that box by?
This just means 90 degrees. The 90 degree, no, the 90 degree symbol means that these 2 are your legs.
Okay.
Okay? So what is this length here?
3, 1.
So this dot on the x-axis is at 3, and this dot on the x-axis is at 4. How long is that base? 1 unit. Okay, so now you have a right triangle that looks like this. Let me draw a little bigger for you. That length is 1, this length is 3. How do I get the hypotenuse?
3.
Pythagorean theorem. Okay, but what I want to do on this is show you how you come up with the distance formula. The distance formula is the square root of the change in x's squared plus the change in y's squared. So, just a minute, I'm going to show you. C squared equals a squared plus b squared. Would you agree with that?
Yes.
How do I get c from c squared?
You got a square square. A square plus b squared, then you get square root.
Square root. If I were to take the square root, I get c equals the square root of a squared plus b squared. Now, does this look a little bit like that?
Yes.
Right? Okay, well how did I get 1? Oh, yeah. Oh, okay, just call it crafty. Okay.
Someone's calling you. This is a mess. That's just what we.
Yeah. I don't feel like it. People are gonna get to see that for a while. I used to just be like, follow Mr. Awkward.
Okay. So this looks an awful lot like the distance formula. Well, a squared really is the change in your x's. Because how did we get 1? We took 4 minus 3, didn't we?
Yep.
We took the difference of your x's. So that's really what the a squared is. How do I get b? It's the difference of my y's. 1 minus a negative 2 gives me 3, doesn't it? Yeah. Okay, so the distance formula is nothing more than the Pythagorean theorem manipulated on a graph. Okay, so let's just finish the problem. Here we have 1 squared plus 3 squared. You're going to take the square root to get the distance. 1 squared is?
1.
3 squared is?
9.
What's 1 plus 9?
10.
And what's the square root of 10? Round it to the nearest hundredth, please. 3.16. So that's the distance.
Wait, how do you, is like the D and the C squared the same thing?
D and C are the same.
So the answer is right.
Yeah. The reason I use D is just to acknowledge that this is the distance formula. Okay.
You said that 1 and negative 2 equals 3, but how? That's not going to be just negative 1.
Your y's. This is a 1 and that's a negative 2. 1 minus a negative 2 gives you what?
I thought that would be negative
1 minus negative 2 is.
3. Oh, okay.
Got it? All right. So that's problems just to help you understand where the distance formula came from. Okay? Let's go ahead and do example 2. Tell whether given side lengths form a right triangle. Okay, so here we have 8, 10, and 14. Those are the side lengths. Now, which side is the hypotenuse?
14.
Why is it 14?
Because it's the longest thing.
Because it's the longest. Okay, so here's what we're asking. I'm not going to put the right angle symbol in there yet because I don't know. Let's say this is 8, this is 10, and this is 14. So now you got to check to see if it's a right triangle. If it's a right triangle, then the Pythagorean theorem will work. So we square the sides, and we add the sum of those squares. Oops. All right, so what's 8 squared?
64.
What's 10 squared?
100.
And what is 14 squared?
164. Oh, my bad. 196.
Yes. What is does 64 plus 100 equal 196?
No.
So no, this is not
This is much.
a right triangle.
Yeah, this is way.
Wait a minute.
I like it.
No, that's
164 does not equal 196. Therefore, a squared plus b squared does not equal c squared.
Oh, you did what? 14 times 14.
You got 196. Okay? All right, yes, Anna.
You lost me.
All right, do these equal?
what does it do?
Okay, so it's not a right triangle. That's all that means. So if they don't equal, it's not a right triangle. So let's show one that is equal. So since you know the answer to this one already. 0.5 is the length of one side. 1.2 is the length of another side. And 1.3 is the length of the hypotenuse. Now, everybody do this on your own.
What?
Oh,
Wait.
you're not doing anything.
Oh, man.
I'm just setting it up to see if you set it up right. If you set it up right, you have to start over. That's what you should have written down as you substitute.
What the heck?
Okay? I'm going to do the next step. When you square those, that's what you get on your calculator. Hopefully you all got that. You got that?
Okay.
Okay, good. Good point.
I'm sorry.
That's all right. Yes, since that is equal, then these numbers form a right triangle. Otherwise, the Pythagorean theorem doesn't work. That's the whole point. All right, example 3.
Wait, that's what we're showing on paper, right?
Yep. Here's an application. Bought a home, you don't have a ladder. You need to know how big of a ladder you need to buy. How big of a ladder?
Where? Just right now.
Yep. Do you need to buy to reach the top of your house?
The roof? I don't have
Because you're gonna have to get up there and clean these spouts out. You need a good ladder. All right, so here's your house. The edge of your house, top of your roof. There's your ladder. Okay. The base of the ladder, you want it to be 10 feet away from the house. You don't want it to be right up against the house. You don't want it too far away. Let's say it's 10 feet.
We just write that's feet.
Well, you're going to see this in your problems. FT is fine. All right. Now you know your house is 30 feet tall. You have the house plans, and the plans say the peak of the house is 30 feet.
Is that a big house or what?
Yeah, it's a big house.
That's a huge house.
Okay. And hopefully the builders built it correctly and it's at 90 degrees to the ground. So, how long does the ladder need to be? How do you do the problem? Okay.
First you need to write down the Pythagorean.
Yep.
Then you need to write 10 squared plus 30 squared.
Yeah, these are your legs because they're attached to the 90-degree angle.
Wait. And then you need to find the square, so 10 squared equals 100, and 30 squared equals 900, and you add them together and it equals 1,000. So then you take 1,000 square, or yeah, 1,000 and you square root it.
Square root. What is the square root of 1,000 to the nearest hundredth?
31.62.
Braden, what?
0.62.
Everybody check his rounding.
Yes.
So you need a ladder that's at least 32 feet. You're not going to go into Lowe's and say, I need a 31.62 foot ladder. No. They'll have a 32 foot ladder though. Okay.
I got home.
All right, so that's an application And really, the correct answer, but since I asked for it in hundreds, this is what you get. But if I don't ask for it in hundreds, you were to assume that you can't buy a 31.62 foot ladder, and you would say, I need a 32 foot ladder.
I'm gonna make one.
Okay.
I don't get how you did example one.
Example one, let's go back to that. Let's, how about we do another example, like that one, okay? We'll do it over here. All right, example 4. Give me a coordinate.
6-2.
And give me another one
4-3.
with a negative.
4-3.
All right, 4 negative. Good. All right, I'm not going to draw this one. We're going to use the distance formula. Distance formula equals, and you have to memorize this.
X minus X squared plus Y minus Y squared. Or minus.
It's negative.
The point of example 1 was just to show you where the Pythagorean theorem is used to get the distance formula. If you want to memorize the distance formula, that's wonderful. You should know it. So, what are my x's, Peyton?
6-2.
6 and 4.
Oh, yeah, it
X,
is.
y, x, y.
Okay.
What are my y's, Peyton?
2 and -3.
Don't forget to put the minus a negative. So what's 6 minus 4?
2.
So we're going to square that. And what is 2 minus a negative 3? 5. So, what's 2 squared? What's 5 squared? What is the square root of 29, Peyton? To the nearest hundredth?
5.9.
3 what?
How can you get the
Hey,
in front of the?
You're right.
Yeah.
Okay, I get it.
Don't erase that.
On our homework, we have to draw the triangle.
If it says to draw it, draw it. Now, if you want to do this, I'll draw it right here. 6, 2. 1, 2, 3, 4, 5, 6.
That's a lot.
2. And 4, negative 3.
I got 6
Okay?
Yeah, it's just confusing because
So that was 2 units. And this was what, 5? Okay, your assignment.
Wait, do you have to make that little formula?
If it asks you to.
Oh,
Assignment.
that's what I'm having to.
Page 140, 2 to 36 evens, and 37 and 38. Good.